Hello everyone and welcome back to my channel. In this episode we'll talk about how you can use the PID function block on Schneider Electric's Control Expert programming environment. This PID function block can be used in Quantum and M580. So I'm going to launch my Schneider Electric Control Expert tool here. So I'm going to go online with the PLC. So if you haven't uploaded the program and haven't compiled, make sure you start off by compiling it. And then you connect to it. Go to your IP address, set your address or USB, and then hit connect. And after a few moments, if you go back to your PLC again, you should see a disconnect if it's connected successfully. And then you hit transfer project to the PLC, make sure to put a check here and hit transfer. I'm not going to do that because I've already synced up this Control Expert environment with the M580 PLC. And I'm going to just go ahead and proceed writing the PID function block. So the PID function block can be written in this area. So if you look at this project browser, expand programs, tasks, and then in the master is where you write your function block program on the logics. So I already have one here called test. I'm going to open it up and close all this. And when your program is online, your background is gray. So I'm going to right click and drop in a function block called PID. Function block Input Assistant, and if you type PID here, it comes up with the PID that you want. So you can give it a name for the instance. I'm going to keep everything consistent and call it _x PID, say 88, and hit enter. So since this thing is live, they say, do you want to make modification? So once you hit yes, everything will turn white, and then you are in edit mode when it's in white, and you can drop your function block in there. So I'm just going to zoom in here. So this is typically what the PID function block will look like. So you have a set point, PV, mode, and para, which is your PID parameters, feed forward, a manual input point, and your output. And you get your output status on this side here, and your status and the error, which is a difference. So let's get started. You can just, I'm going to create a new variable called _x SP and hit enter. And if the variable doesn't exist, they'll prompt you to create one. It's going to be of type real, and they're going to hit yes. So I'm going to do the same thing with PV as well, _PV. And the mode is just going to be the _x MODE, and you hit enter. It's going to be called of type mode PID. Just keep that in mind. And parameters _x para, I'm going to call it PID and hit enter. This is going to be called data type is going to be called para PID. And feed forward, I'm just going to put 0. Yman is a manual input or MV on a PID world. I'm going to call it _x MV. This is going to be type real as well. And then output is going to be called _x output. I'm just going to call it raw. And this is going to be real as well. So if everything's okay, there won't be any red underscore on any of the variable. So I'm not going to trap any of this. So if you want to keep an eye on what's going on in here, you can actually create an animation table. But before we do that, let's build changes. What build changes does is that it uploads the changes that you made into the PLC. As you can see, the background is becoming gray, which means you're going online with the PLC. And as soon as you're online, you'll see all these values being assigned a value of 0, but your anything with mode and para PID will still maintain its original variable state. Now, let's create an animation table to actually monitor each of this tag name and also be able to change them. So in order to do that, you go to variables and FFB instance, which is function box instance. You go element variable. So you know that your variables are all _x something. Put asterisk in here and hit enter. A couple of them should come up. These are all native, but the para mode and para PID is not here. Now to enable that, click on DDT, and then you can see all of them in here. You can see these are just raw values, right? I want to touch a bit based on this one here. So the native ones are pretty straightforward, but the DDT ones are a bit different. In the world of Schneider Electric Control Expert, DDT is actually a structure. So you can see if you assign this to 1, which means it's manual. By right, it should be 0. Halt as 1 to halt the PID process. And you can enable the PID to allow you to do the control. Normally, you just put 1 in all of them. And then on the parameter for the PID, you can actually put a real value for gain and T. Let's watch all these tags here and try to manipulate them as we go along. So if you select all this and hit right click and you say new animation, so it creates an animation table for you on the animation section here. And now you can see this is the live value that you're actually looking at. So I'm going to close this guy here. Sorry, this guy. Close this guy here. View. I'm going to try to bring back my project browser. At least it is there. And clean up this section of the project browser a bit more. Move a bit further. And window and do a tile. So I can actually see both of the screens together. So in order to make this move or test, what you need to do is, first of all, manual, make sure it's off. You don't want in manual mode, and make sure that your PID is not halted. So these two must be off for the PID to function in auto or remote mode. So I'm going to enable my P. In order to enable this, go modification, and when you hit modification, anything that's bold in Control Expert, anything that's bold, you can actually change it. Red means it's false, and green means it's true. I'll show you what I mean by that. So I'm going to enable this guy here. You can see this is green. It's like true or false, right? But black numbers are just real numbers. So enable all that, including my D, so that I can start using my gain with 2 as gain, and then 2 seconds here, 2 seconds for integral, and maybe just 1 second for derivative. Could never say that well. So another thing is that you can actually change the max and min. Keep an eye. This is our max and this is the min. So normally on a PID block, my range is always 0 to 100. So min is 0, max is 100. So it allows the PID to output anywhere from 0 to 100. So now I'm ready to actually simulate the value on the PID. So this is going to be a direct acting. So let's say, for example, if my PV is, if I set my set point as say 10, PV is definitely lower than the set point. That's why you can see that the PID is starting to act up and trying to go towards 100%. I can amp it up a bit more, right? And it goes really fast. So I'm just going to put it to say 20 for now. So if I start to taper my PV, which is a process variable, towards say 15. So if I move it up to 15, you can see that the output moves a bit and it goes back to 100 again. The PID is not really tuned yet, so I'm just going to try to put some minimal value so at least it's not so reactive. So that's part of a tuning that you can do and whatnot. So still your PV is lower than your SV, that's why it always goes towards 100%. So if I were to go close to 20, you'll see that the value is more stable now. It's not crazy. It's your process value. Pass your set point of 20. You can see that the output will start to go down towards 0%. So this is a direct acting. So if you want to do reverse acting in Schneider Electric, all you have to do is put a negative on your gain. No, it's not the best way to do it, but this is how I found to be effective. and you can see that PV is higher than your SP. It's going towards 100%. So I'm just going to amp up this thing a bit more so actually you can see the result faster. So if I go back to a positive gain, you can see that now it's direct acting. Going to increase my PV a bit more so that the deviation between the SP and TV is larger, and the error is about 20 now. You can see here. So you can see this is moving faster. You can actually move your gain faster by increasing the gain a bit more, and you can see it changes faster. Right. So now it's direct acting. If you put a negative here, it'll give you reverse acting. There you can see it's going towards 100%. Again, if I were to go 0.1 without the minus, 0.1, and you'll go the other way. So this PID is actually set to give an output between 0 to 100% as defined by these two parameters. You can also output a speed, say from 20 to 60 Hertz. You can do that too, but sometimes you need a PID to actually speed up 0 to 100% and at the same time do a scaling on the side. Now this is how you do it if you have to do scaling on the side. So I'm going to zoom out a bit more, close this, and I'm going to move this a bit so that I can enter into an edit mode. As you can see, it turns white, it goes into edit mode. In order to do a scaling, you need to put a function block call, right click on this white spot here, section here, worksheet, and press right click, and then on the context menu select FFB Input Assistant. Over here you type scaling and hit enter and just drop the function block in here. Over here on the input, all you have to do is to connect your output from the PID into in here. And it also takes another variable called para scaling. Double click this guy here, underscore, I'm just going to give it the same kind of name, x para, and I'm going to call this scaling, scaling. Hit enter, and you can see this, it has to be a data type called para scaling, and put check next to it. Let's assign a value here as well, underscore x, let's call this output. Since this is raw, it is going to be called engineering unit, like that. And it's going to be type real. So we're going to watch this and this variable in our animation table there again. We go to variables, you go element. If you do this and make sure you put DDT, you will see that you have scaling and you have output EU. So we're just going to monitor this. Right click, new animation table. Okay. So now this is what you have. But if you see that you have a ERR here, don't worry. All it means is that you need to load the program, which means the offline version of the program has the variable, this and that, but this has not been uploaded to the PLC. That's why you see hash error, exclamation error. So what you do is you go build changes. So what it does is that it takes whatever changes that you make to the function block and uploads to the PLC. So as soon as you go back to test again here, you can see everything is grayed out right now. So which means that you are online with the PLC. So I'm going to try to close this guy here, and I'm going to try to tile this view vertically, arrange it tile. And I'm going to zoom out a bit more here so you can actually see everything. Arrange it a bit more. So like I said, you have your PID block and you got your scaling block and you got your PID running and what have you. So you have your SP and DP and all the good stuff in there. I'm gonna reverse this so that you can actually see your PID moving. Hit modification. Again, anything in bold you can change, but anything not in bold you cannot change. But on this setup here, everything can be changed. Put a negative in here, and the output will start to move, and it's gonna fade the output to the scaling block. So the scaling block has a few parameters here on this scaling parameters. So this is going to be the input min and max. Our input min and max is 0 and 100. So we're going to put min at 0. Just be careful, this min is in front, this min is at the back, and this max is on top, right? So read your parameters, make sure that you're entering on the right spot. So it is expecting 0 to 100% from the PID block, and it's going to output whatever you want. 20 Hertz is your min, and you're going to output 60 Hertz. So it does a linear interpolation between 0 to 100 against 20 to 60. And that's how you get that. So as you go towards 50%, we're probably looking at about 40, 45, and this is about right. You can actually see 65. And eventually when this thing goes to 100%, your output should be 60 Hertz. I'll just give it a few moments here. I'm gonna help them by increasing the gain a bit more so that it can go faster for this video. 90, see it's approaching 60, and once it lands at 100, you get 60. So if I were to reverse this to positive, so you get direct acting, you can see your output is reducing and your output on the scale block is reducing as well. Eventually when this goes 0, this will stop at 20. You can help them by increasing the gain a bit more just for this test. So it's just speeding up a bit here. And as you can see, the PID is speeding up 0%, and the scaling block is outputting 20%. So anyway, so this is a quick demonstration of how you can use the PID block with the scaling block. PID block does not always require scaling block. Scaling blocks is exception. If you need it, you can use it. And I hope this tutorial will help you in every aspect there. Other than that, you have an awesome day. Bye now.